Hello guys, welcome to Behind the Equation. I'm EGX. Today's video is going to be about forces. We're going to talk about forces and type of forces and Newton's first law. So let's get started. So the first thing we're going to do is, what is a force? Okay, for example, a force. A force, in simple words, is just push and pull and pull. So what this means? So for example, if I have this ball here, so when I push it like that, okay, this is a bit rough. Okay, so it's no, okay. If I push it and if I pull it, I apply force on it. So when I push or pull an object, this is considered a force. So this is a force. But the force can do something like a force. First thing, the force can change the movement of an object. So let's try to change the movement of an object. So what this means? Okay, so we have this ball. We return to the same ball. This ball here at rest. All we know it's not moving. It's a bit moving, but now it's at rest. It's not moving. But when I apply force on it, like if I push it, it starts moving. So the force will change the movement of it from being at rest to being at motion. And same saying, if it's moving, okay, and I apply force, it's stop. So so the force can change the movement of an object. If it's at rest, it can't change it to be at motion, and if it's motion, can't change it to be at rest. So this leads us to Newton first law. Okay, what Newton first law? Newton. Okay, first law says, in simple word, it says the object be in the same motion state until unbalanced sorry if my grammar is loud, forgive me, unbalanced force acted on it. Okay, so it's same thing here. If it's actually at rest, okay, when I apply force, it's changed to be at motion. And if it's at motion, if I apply force, for example, if I apply force in this direction, it's a stop from being at motion to be at rest. This is Newton's first law in simple words. It's just Newton's first law. An object at rest keep being at rest until an unbalanced force acting on it. And same thing with the moving, with the object in it's the same with the object is moving. Okay, so we move to but for example, I mentioned the word, but IDK, if you noticed, it's called this unbalanced. Okay, unbalanced force acted on it. So forces, what's unbalanced for? So for example, this ball. Okay, why is this ball not moving? Anybody can tell why this ball at rest, why it's not moving. You're gonna say because you didn't apply a force on it. Okay, that's true, but if we but in reality, this ball has two forces acting on it. But you're gonna say why this ball at still and what this forces. So we move to the type of forces. The forces have type. For this ball, when it's a table or anything that's not moving on a table or anything, have two forces acting on it. First one is the weight force. I'm sorry, weight force. Okay, what's the weight force? The weight force is the force made by gravity. That's it. The second one is the normal force. Normal force. Okay, that's it. So we have weight force and normal force. What's weight force? We said it's it's the force made by gravity. Okay, and normal force, it's the force how can I explain normal force? Okay, we're gonna see what's normal force. So for example, we have this ball. This ball, if I want to use something called FPD or free body diagram, how it's gonna be. So let's draw an FPD. Okay, let's say this is a ball. It's a box, but let's say it's a ball. Okay, it's easy. Okay. So let's say that's our box. Okay. This box has two objects acting on it, the normal force and the weight force. Okay, normal force and weight force. Yeah. Okay. So you're gonna think if it's two main forces acting on it, why it's not moving? That's a really good question. Okay, every force has a direction. The normal force direction is up, or you're gonna say it's positive, and the weight force have a direction also down. Okay, or you're gonna say negative. Why it's positive and negative? Because of this graph. Okay. We here have the y-axis, and here we have the x-axis. Here we have it's positive, and here we have it negative. Why the y-axis? Because if it's horizontally, not vertical. So the force is horizontal. The gravity force is horizontal. Okay, and the weight force is come from gravity, but the normal force is coming from the things that hold the box. For example, if it's a table, the normal force is from the table. Okay, but why it's still returns to the same question? Because these two forces are equally. So for example, let's say this box, the weight force is applying on this object of a force equally to, for example, 50 Newton. Okay, 50 Newton. But what? It's minus because downward, it's in the negative side. Okay, minus 50 Newton. Okay, and the normal force actually it's 50 Newton. But what? Positive 50 Newton. So both are equally. Okay, but in different directions. So if I want to add this up, plus 50 plus minus 50 Newton, this means nothing. So it's 50 minus 50 equal 0 Newton. So when I have zero force, the object, it's not gonna move because I don't have any force. That doesn't mean the two forces are not exist. No, it's mean the two forces cancel each other. They are not exist. They canceled each other. Okay, because they are in different direction but equally. And if there's zero force, 0 Newton, which is the unit of force, if there's no force, the object gonna stay in the motion he is. So at rest, it's gonna still be at rest. If it's not moving, it's gonna stay at moving. According to Newton's first law, the object being the same in the same motion state until unbalanced force acting on it. But here there's no any force. There's no unbalanced force, so it's gonna stay at rest. But if, for example, the weight force, okay, was bigger, let's say it's gonna be 50 Newton. Okay, it's gonna be 50 Newton, and this is gonna be, for example, 60. Okay, it's gonna be equal minus 20. I'm gonna say minus, so it does not exist. No, it stands for the direction, not for the attitude, not for the value. The value is 10, but the direction of the attitude is 10. That's so up. It's gonna be up. It's positive equal up. So minus equals downward, downward, positive upward. That's it. Just the sign for the direction, not for the for the value. Okay. That's it. Okay, but if this, we're gonna left with minus 10 newton. That's mean the box, not if we have a force. Okay, there's an unbalanced force acting on it, which is 10 newton. So the force gonna keep falling until it hit something bigger or equal to, which is gonna just keep or return. So for example, this ball, this ball here, if I let it go, the gravity is pointing downward. In I can calculate, but I don't want to. I don't want to use equation for today's video. It's just gonna be for theoretical physics and intuition, and we're not gonna solve the equation for today. It's really basic, but I don't want to overwhelm you. So for example, this actually the gravity is pointing down. The gravity never turns off, but my hand, my strength is holding it up. Okay, upwards. So both are balanced. But if I let it go, it's gonna fall because of gravity. But the table applied a normal force equal to the weight force. Stop it. If this does not exist or something, it's gonna keep falling forever until it hits the ground, and the ground gonna stay immovable. So that's it. Because I'm holding it, making a normal force in the opposite direction of the gravitational force. If I let it go, it's gonna be falling because there's no, there's forces are not balanced. That's it. So that's it for today. We're just gonna learn about forces. The force is push and pull. The force can change the movement of an object, and we saw this here. When I let it go, it's fall. Okay. We introduced Newton's first law: the object at rest, being at rest, and the object at motion be at motion until unbalanced force acting on it. That's it. We introduced weight force, normal force. That's it for today. But one note: forces have direction. I told you. But if the object is moving this direction, okay, the force, and I apply a force in the same direction, it's not gonna cancel out, or it's gonna the speed of it, okay, gonna increase, and we call this acceleration. Okay. And if an object is moving this direction, okay, and then apply a bigger force in that direction, it's gonna first stop and then move in the direction of the bigger one. So we're gonna talk, if you didn't understand this, it's not a problem, because in the next video we're gonna introduce speed and velocity, acceleration, Newton's second law. So if you didn't understand anything from the last example, don't worry, because we're gonna explain it in the next episode better and clearer. Just like to give you just an idea, just the idea what the next episode is gonna be. That's it. Don't care about this for now. Just don't care about it. But just if you understand forces, that's really good. If you don't, I can try explain it in the next video in a better way or something. The next video, as I told you, we're gonna talk about we're gonna talk about Newton's second law, and we're gonna talk about speed versus velocity and acceleration. What difference between speed and different versus velocity. See you on the next video, and remember, every equation there's something behind it, and we're here to discover it. Welcome to my equation.